Hey, and welcome to my series of Rust for absolute beginners. I had some feedback, my videos are kind of complicated, I know that. And actually a bunch of people that go to my site wanted to know how to actually get started with Rust. I thought there are enough tutorials, but maybe I can explain it a bit different. I have 5 years of experience now, and sometimes I get the feedback that I can explain things quite well. So I just give it a try. And maybe, I will still upload some videos in between that are a bit more complicated or extended topics. But with this series, we will just look into the very basics that even if you never programmed, hopefully you can follow a bit if you're interested in programming languages in general or in Rust. Yeah. And let's get started. So what Rust is a programming language that is compiled. So if you want to choose your language, you have the option between JavaScript, Python, C++, Java, whatever. The difference between the languages is mainly some are just-in-time compiled. That means you always need to have the tools installed on the system to run it. That's in Python, for example. And some others are pre-compiled, that is Rust and C++. Those are usually faster and lower to the system. So you can control the computer a little bit better with it and have more control over what your program does. I think, usually like C++ is very complicated to write. It needs a lot of experience. And that's why people wanted to go often with Python first or JavaScript first. But I think Rust made a lot of the pain points so much easier than C++ that now it's actually selected in a lot of projects where you would usually select JavaScript as well. So for example, Amazon Prime Video, the user interface, the UI is actually programmed in Rust, which would have done before. Usually people would take React or something for it. Then Disney, the Disney video service, is also programmed in Rust. We have a lot of browsers that are using it, operating systems, cars. Now it's actually everywhere, and you can do everything from a microcontroller and even up to a website and backend services. With Rust you can program everything. That's kind of cool, and that's why I think also it's a nice language to learn. Because you can just do whatever you want. So let's have a look at it. How do you get started? Rustlang.org. Click Get Started, and it immediately shows you how to install Rust for your computer. Here you have to, I'm on Linux, and on macOS it's basically the same. You just do this, open a terminal. I think also on macOS it's called terminal, sometimes it's called console, and then you type in this command. Now it's downloading the installer. It wants to install Rust. I just proceed with the standard installation, press enter, and then it's installed. I can run this if I want to have it here in the shell. And then we have cargo as a tool. On macOS it's basically the same. On Windows you have to download an installer. But if you want more help, you can go to this Rust book. Here, rustlang.org/stable/book. That is a really nice getting started guide for Rust. So here we have the installation. And if you have any problems, look here. Here you see on Linux and macOS, you run this command in your terminal. And then on macOS, you have to also install Xcode select. This will install the C compiler. We need this also to compile code in Rust. This can be quite big, so you need, I don't know, a couple of, I don't know how much, maybe 20 gigabytes, 40 gigabytes, I don't know. You need a bunch of free space on your Mac to install it. On Linux, most of the time, it's already installed, everything you need. Sometimes, for example, on Ubuntu, you need to install this build essential package. That's here, sudo apt install build essential. I type in my password. Oops, I have to type install, right? And then you see build essential is already installed on my machine, and this will give us GCC. Yeah, that's the C compiler. You can also just install Clang or GCC. And if you're on other Linux OSs, you need to check how to install GCC or Clang. Yeah, and I think CC is what we need. That is kind of the linker. I'm actually not entirely sure what CC is. Does it say it here? No. Bad guides always in those old programs. Yeah. And on Windows, you see, you just install here. You go to this link, and then you can install, I don't know, it doesn't show up now because we're not on Windows, but you have to install a UI program that you download, and then you just follow the process. Okay. Now we can do Rust C version in our terminal, and we see we have installed Rust compiler at 1.92. The tools we usually use is just, there's Rust up, or maybe first, always follow these instructions. There is also sometimes on some Linux operating systems, also on Mac with Brew also, you can install cargo via the package manager. So for example, like this. I don't think here it doesn't work, but on Arch, for example, there's a package. I wouldn't recommend to do this because RustUp is such a great tool to manage your Rust installation and is the default. I would always go with this, that you don't end up in bad situations in the end and make things complicated. Always follow this guide. What else do we have to do? I want to show you the tools. So RustUp is basically just what you do, use to update your Rust installation. So I can run RustUp update. So here you see, there's a new beta version. I had the beta installed. So now it's downloading this and installing it. You can also use RustUp to install different tool chains if you want to cross-compile from Linux to macOS or something like this. But this is extended. Usually you don't use RustUp for anything else than to update. What is the next topic? If you want to see the target list, RustUp target list, and then you see all the targets you can compile Rust for. So those are, here you see some Apple iOS, Linux, Windows, and so on, Android. And the tool you will use all the time is Cargo. With Cargo, you can do everything. You don't need to use the Rust compiler directly or so. You have Cargo. If you're on Cargo help, you see some of the things you can do. So you have Cargo build, Cargo check, Cargo clean, doc, new, add, remove, run, test, and so on. Bench, Here you see all the things. But the main commands we will use is Cargo build to build a program. There's no Rust. Cargo new to create a new project, or with lib if you want to build a library, and Cargo run. Those are the main commands. So let's check it. Let's just create a new Rust project and let's get started. What do we have to do? I go to my development playground. I think I already made a hello world here. Let's remove this for now. And you have to run cargo new, and then hello world, or whatever you want to call your project. You cannot call it test, but everything else works. Let's try it. So now, what did it do? It was creating this folder, hello world. And now we can start it, Or we can already take a look inside. Maybe let's have a look here first. There's the folder hello world, and it contains this cargo.toml file, and it contains a source folder with the main.rs file. If you enable looking at hidden files on your operating system, then you see there's also a git ignore file and a .git folder. So it initialized a Git repository. If you haven't heard of Git, it's just a version control. So you can track your changes you do, and publish it somewhere. So the git ignore file, will just ignore the the target folder, which is created if you build a project. There is the compiled file in the end inside. And the .git file contains is a folder that is just used for Git to store the changes and so on. So let's remove those hidden files. We have the cargo.toml file. This is your main project configuration file. So there you define how your project is called, which version it has, and you can add all the dependencies you have to other libraries. For example, if you want to use some help, for example, if you want to create random numbers, then you need to use a library, and you can add this here. And in the source folder, this is main.rs is the main entry file into your Rust program. So the program always starts in the main.rs file. You can create more files with Rust code and combine them, but it always starts in the main.rs file or in the lib.rs file. If there's just a lib.rs, that means this program is a library and is meant to be included in other Rust projects, but it's not a standalone program. And the main.rs file means it's actually a standalone program. You can even have both. And now to edit the code, you can look inside of here and see it contains function main, and it will just print hello world here. That's all it's doing. And I think if we open the cargo.toml, you can check that it just contains the name of the package, the version, the edition of Rust. We're currently at edition 2024. They do Rust editions just to have breaking changes in the code, and you can opt in to use a new edition. I would always recommend just leave it as a default, because you can still use old edition dependencies. If you have a library that is still 2021, you can still use it here inside, and then only this library will be compiled with the 2021 version. And here you add your dependencies. But here it's a bit bad to write code in this text thing. That's why you need an editor. For Rust is cool because it's very easy to use with a lot of code editors. Because of Rust Analyzer. Rust Analyzer is a tool that checks all the code and speaks to the IDE, the code editor you are using. So there's Rust Rover, for example, that you can use. There is Visual Studio Code. So Code is the editor that is most used. If you're a beginner, maybe it's a good idea to start with VS Code, because this is also mainly used in the industry. I use Z-Editor. That's this one. Z-Editor is nice. It's also written in Rust. It's very fast, and it is pre-configured for Rust. So it's kind of nice and easy to use. I think now it's also for Mac OS, Windows, and Linux. For Linux, you just run this command, and then it's installed. For Mac OS and Windows, you download it here. And for VS Code, you go to this site and can download it for Windows, Linux, or Mac. So it's your choice what you want to use as an editor. I will show you first VS Code because it's so commonly used. So maybe I have to close the file system here. Whatever. Development, playground, and our Hello World program. And we can run when code is installed. I did this already. Then we can run code dot to open the VS Code project in the current directory. Or if we are in the change directory back, if we are in playground in that folder, then we can do code playground, code Hello World, And this will open VS Code. We trust the project. And then you see here we can modify the file. But VS Code is not by default able to handle Rust projects. That's why you still need to install something. You go to extensions. And then you need to, here it's already showing up, you need to install the Rust Analyzer. This is the main thing you need to install. So let's click on it. I don't know why this doesn't work now. Hello. Maybe I have to restart it. yeah, Rust Analyzer and install it. Trust Publisher and install. And this will give you all the tools you need. So now we go here. Now you have this little run icon that is from the Rust Analyzer, and you see immediately if something is wrong. So here it shows up. Oh, this is something that is wrong. So that is why a code editor is so great to use. There are some other extensions which are nice to use. So for example, Even Better Toml. This will just give you the option to inspect those files nicely. Here you see it's not highlighted, it's all white. And if we install Even Better Toml, then also this Toml file is highlighted. And you see missed errors here. For example, if we do this, then it shows, oh, there's a problem. Okay, so that's how we start. If you use Z, just go Z hello world. Z will automatically work with your main function. I don't know what happened here, discard. So that will automatically work with your main function. Here you see it. Here's the play icon, so we can start the program. And if we do a change here, it will also show up. So that's great. But also on Z, you don't have code highlighting for the Toml files. You just click here, go to extensions, search for Toml, and then you have here the Toml support that you can install. That's basically all you need to get started. All right. Now let's try to run the program and see what happens. If you installed the C compiler on your system, you can just start. Just press play. And if you're in this kind of IDE or on code and you press play, you should see the output here. It shows you hello world. You can also rerun it. Here, the program. And cool, that works. You compiled your first Rust program and ran it. So what else can we do? If you don't have this play button here, or you want to use it from another terminal, you can go to the terminal and run cargo build or cargo run. Cargo run will also build the project. So cargo run is basically the same as pressing play here. There are also more commands like cargo test. This will run all the tests you have in your repo. Currently, we have 0 tests, but they are all okay. And there's cargo check to check if something is wrong. So for example, here you can do this. We run cargo check. And we see, oh, cannot find printle. A macro with a similar name exists print. So that's cool. Rust is really helpful in those in showing those error messages. But you also don't need cargo check. Actually, it's just enough to run always cargo run or cargo build, because it will also show you the problem. All right. Maybe I just show it one more time with code, how it looks here. In code, you go to the main file, you press run, and you see it works pretty similar, right? And you can also open a new terminal and just run cargo run here. Pretty much the same. All right. And the last thing we do in this video is I will show you what this here actually means, because we run this code. So function, you can also hover it. If you have an IDE and Rust Analyzer installed, you can see always comments here, documentation. And FN means it's a function or a function pointer. Functions are the primary way code is executed within Rust. Function blocks, usually just called functions, can be defined in a variety of different places and be assigned many different attributes and modifiers. Standalone functions that just sit within a module, not attached to anything else, are common, but most functions will end up being inside impl blocks, either on another type itself or as a trait impl for the type. Way too much information already, but a function is just where we define code in modules, and so we can organize code better. and we can put things in functions. Here it's a macro, it's print line. And the difference between a function and a macro is when we put print line as a function here, you would call it like this. Okay. And a macro is something else. A macro has this exclamation mark, and the main reason why there is a macro is functions can only receive the exact amount of parameters that are here. Yeah, so you can define parameters, and with macros you can dynamically change how much is in there. So we can add more stuff. For example, we can do this, yeah, or we can print 1. Let's print it, run it, and now we also print 1. Yeah, it will be put here. So that's the main reason why there are macros. Yeah, there are more things you can do with macros, but just so you know, macros have more functionality than functions, but are in the usage pretty much the same. Right? All right. That's the first video. I hope you could follow a bit. Yeah, you can give me feedback if that was too fast. I think I always go a bit deep, but yeah, I think that helps to understand Rust, yeah, and to understand what's actually happening. Maybe one more thing, yeah, the target folder, because it wasn't here yet. The target folder contains your compiled program. So what we run here, you see running target debug hello world. And if we look in here, here's this hello world program. We can look at it in the file manager. You see it's 3.9 megabytes. And this file is something, yeah, we can put this file anywhere else. We can even put it onto another computer. So let's put it in documents. Yeah, now we have it here. Open a terminal and run it. Hello world. And you see it still contains everything, and it's shareable. Yeah, so I can send this file to you on your computer, and as long as you're using the same operating system as me or the same hardware architecture, it will run for you. And that's the cool thing about compiled languages. Yeah, you just have one file that contains the whole program. And the code inside is hidden, a little bit hidden. Yeah, it's not that easy to reverse engineer it. But it's quite large, yeah, because it was a debug build. So usually what we do is cargo run release. And now it does an optimized build. I think it's showing here, release profile optimized. And the big difference is, yeah, if you really want to have a file that you send somewhere, I would always do a release build, because the release build will optimize the code. It takes a bit longer to compile. But then you see it's only 500 kilobyte instead of 4 megabyte. And the program will run much faster, yeah, sometimes 10 times faster than in the debug build, because the compiler takes more time to optimize things, yeah, to cut things away. Yeah, that is the basic of a Rust program. The next videos will be a bit shorter. Yeah, the first one had to be quite long. But thank you for watching, and see you next time.